Good evening to everyone. On this video, I will be giving a brief product presentation of the global analysis of Tremuri project on masonry structures. To create a new project with Tremuri, first we are going to select File New from the upper toolbar. The program is going to ask us to assign a name for a new project, and we click OK, and the model is going to be created. Then, to continue setting up our model, we are going to be asked to select a couple of options, such as the building type that we're going to see here, that we can choose between new or existing, and the technical standards that are going to be used in our program. As we see here, for this case, we're going to use Eurocode, and we are going to see that the program has already preloaded all the parameters for this specific code. Of course, we can change them if we wish to do so. We click OK, and the program is going to be created. Tremuri is divided into different environments. First, as we see here, on the upper left part of the screen, we have a set of icons and a toolbar that are going to be common for the whole program, and different tabs that are going to represent the different environments. For each of those environments, we're going to have a specific set of icons. To begin with the creation of our structural model, first I'm going to go ahead and import a DXF file that we are going to use as a template for our model. This is going to be very useful because it's going to allow us to quickly insert all the alignments. With the help of the CAD engine inside Tremuri, we are going to be able to quickly insert all the alignments that are going to represent all the walls in the structure. As we see here, we have automatic snaps for relevant points of the DXF file that we just imported, and we just right-click to finish the insertion of the alignments. As we see here, we can do this very quickly by tracing the axis of the walls, and we have more options that we can use, such as the dynamic input, that is going to be very helpful in the insertion of alignments that have a very specific length that we want to insert. As we see here, we just go ahead and select, and it's going to tell us the specific length of that environment in the scale that we selected, and more graphical tools that we are going to use to draw our structure. And of course, we can turn the snaps on or off as we wish to do so. And we have more options for our alignments, such as we can delete them, we can offset them, very similar to many CAD programs in the industry. The next step in the definition of our structural model is to go into the structure environment. That, as we see here, we have specific set of icons specific to this environment, such as the definition of materials, the ability to manage the properties of each material that we defined, and of course the different elements that we can insert into our structure, and the elevation view input that we are going to see in a specific video. First, we are going to insert a wall. To insert a wall, we first need to select an alignment and open up the Define Characteristics window. As we see here, it's going to give us information of whether this entity has been defined into plane mode or into elevation view input. As we see here on the window, we have different options of different elements that we can assign to this alignment, such as masonry panel with a reinforced concrete tie beam, or with a steel and wooden beam, masonry panel with a tie rod, a reinforced concrete wall, reinforced concrete beam, a steel or wooden beam, and also a tie rod, or we can just leave it with no definition. In this case here, we are going to assign a specific thickness to the masonry panel, and we are going to choose the material of this masonry wall. We have preloaded materials according to the specific libraries of the regulation codes that we chose at the beginning of the model, but we can also import new libraries or create new materials or edit existing materials. As we see here, we have more options such as the choose of reinforcements or characteristics of the foundations, but for now we are going to leave them as they are. Once we define one of our walls, we can see with a hovering of the mouse over the alignment, we can quickly see the main characteristics of the wall that we just defined. What I'm going to do here is going to select the rest of the alignments and assign them the same structural attributes as the first wall that we just inserted. Now we're going to go ahead and insert the openings. For the insertion of the openings, a new window is going to open up, and it's going to allow us to select between two different insertion modes. As we see here, we have a single point or 2 points in the wall. If we choose the insertion mode of a single point, we have 3 different choices depending of we want to choose one of the edges or the geometrical center of the window to select it. As we see here, what I'm doing here is using the geometrical center of the window to insert all the openings of the structure. All the openings are going to be inserted with the parameters, with the geometrical parameters that we see on the right side of the screen. And in the case, for example, that I want to insert a door, it's very simple. I just need to turn h1 into 0, which is that height, and change the height h2, and what are we going to insert are going to be the doors of the different rooms on this structure. Once we finish, just right click to exit the environment, and we are going to see our floor plan with all the openings already inserted. We can just go ahead and insert columns that we're not going to do in this specific model, and floors. As we see here, floors, we can choose between different typologies of floors that are already predefined on the program. With the help of this image that we see here, we're going to define all the geometrical parameters, and we are going to see in the left side of the screen that all the computed values are going to be calculated automatically. We just go ahead and click OK and select the corners of our floor, the vertices of our floor, and right click to finish. Then we are going to select the reference element to see if the loads are going to be parallel or perpendicular to that reference element, and the load window for floors it's going to open up. As we see here, we have the option to insert all permanent and accidental loads and the coefficients that are going to be used in the calculation, and we can continue with the insertion of floors, as we see here, with a different part of the structure. Right click to finish, then we choose the reference element, and in this case we just go ahead and click OK, and our floors have been correctly inserted. If we go to the 3D view environment, we are going to see more options on how to visualize our structure. We can rotate our structure and see how all the insertions that we do are changing our structure. We can zoom in and out. We can choose to visualize specific levels and specific elements. As we see here, we can show or hide walls, beams, columns, and also we can change the transparency of the floors or the roofs if we need to do so. Next, we're going to see the levels management environment. As we see here, the levels management window allows us to manage our different levels and to choose their height, to add or delete levels. And with this specific option here, we can duplicate a level with the same structural properties that we already defined, which is very useful in the case of regular structures. As we see here, in this case, I have duplicated the level and the structure is coming together. Our next step is that we select the second level that we just created, and we are going to go ahead with the creation of the roof. In this case, to create the roof of the structure, we are going to click on the icon, and as we see here, the icons are going to change slightly. They're going to be similar, but they're specific to this environment of the roof creation. We have options to create walls, openings, insert columns, insert loads, and that are very, very similar to the structure environment, but in this case, they're specific to the roof creation. In this case, we are going to create a roof that has two slopes that are perpendicular. So we are going to create nodes and insert another alignment that is going to be present only on the roof environment. And we're going to go ahead with a step that is crucial on the roof creation, that is the assignment of height to the nodes. As we see here, the node elevation can be set to as whatever we want, and once the nodes have an assigned elevation, as we see here on the screen, they're going to turn red. Next, we are going to insert walls that are going to be located specifically on the roof. As we see here, the define characteristic windows, it's going to be open once again. We assign the thickness, and in this case, I'm going to right click on a specific alignment and I'm going to modify it to, instead of a wall, I'm going to insert a wooden beam. So we just go ahead and select it, and we are going to select the geometrical definitions, dimensions of this beam, and select the material from the library. Just click OK, and if I hover my mouse, I'm going to see that all the structure has been correctly defined. Next, I'm going to insert the roof slopes. In this case, I'm going to go for a rigid floor, select the vertices, very similar to the case that we saw on the insertion of floors, and the load window is going to open up, and we just click OK, and the roof slopes is going to be correctly inserted. In this case, we can choose the load direction definition. We can make it in one direction or bi-directional, depending on the characteristics of the roof. And I'm just going to go ahead and create my third and final roof slope. Just right-click to exit, then I select the reference element, and in this case, I'm going to make it parallel to this element. So you see here, our roof has been correctly created, and just click on the icon to exit the roof environment. If I go again to 3D view, I'm going to see how my roof has been correctly created, and I can rotate the model and to see it if it has been created the way I want it to. Once we've finished with the creation of our structural model, we can go ahead and perform a fray by macro element analysis, or which is to say a pushover analysis. Once we go into this environment, the first option is going to be to create a mesh. So the calculation of the mesh is done automatically, and also more checks or verifications are performed automatically before the calculation to see if we modeled our structure in a correct manner. So once the mesh has been created, the model is automatically saved in the allocated folder, and we are going to see a plane view with all the names of the walls and the names of each one of the nodes, as we see here on the screen. If we click on the icon to load select wall, we are going to see our screen divided into two areas where I can select each one of the walls on the left side, and on the right side I'm going to be able to see the mesh that has been calculated with rigid elements, also rigid nodes, and masonry piers and masonry lintels. Next on our preparation for a pushover analysis is the definition of the seismic load that we are going to use. In this case, we can load the accelerations for each limit state, or we can also, if we want, we can load a spectrum diagram if it's very specific of the area of where the structure is located. Then we are going to go ahead and click on the pushover icon to perform the pushover analysis. The next step is going to be to open up the pushover analysis window. Once we open this window, we are going to be able to choose between the different parameters of the specific analysis that we want to perform on our structural model. As we see here, the new window it's going to open, and one of the first things, the fundamental things that we are going to choose for our analysis is the control node. We have more information on specific videos and about how to choose correctly this node. In this case, I'm going to select the level 2 and node 9, and the kind of displacement that I want, it's going to be the average displacement of the control node. On the other hand, we are going to see a list of all the possible analyses that we can perform, and they are going to be differentiated between the seismic directions, the seismic load, and their eccentricity. Also, we can choose the iterations that we want to perform in our calculation, the number of sub-steps of our pushover curve, and we can filter out the specific analysis that we want to perform. Just for this case, I've just selected the analysis 1 and 5, and I'm going to go ahead and run the selected analysis. Along with the pushover analysis, I have more options such as the pushover calculation of a single wall and the linear analysis calculation. Once the pushover analysis is finished, I can go ahead and open up the results window. It's going to give us a list of all the analyses and their relevant coefficient that have been calculated for each one of those analyses and for each one of those limit states. If I go to the results details window, I'm going to see that the window is divided into four areas of different that are going to showcase different information. On the upper right part of the screen, I'm going to see the distorted wall image that is going to show us the deformation for each one of the elements. On the bottom left, I'm going to be able to choose between the different walls on the plan that is currently active, and on the upper left part, I'm going to see the list of all the different analyses. If I go into the results details icon, I'm going to be able to see which verifications have been satisfied or which weren't satisfied, and all the analysis parameters used in that specific analysis. I can open up the legend to see what each one of the colors on the wall mean in terms of damage, amount of damage, and type of damage. Also, I can open up a 3D view of the entire model to get a glance of the damage state of all the elements on the structure in a specific sub-step. As we can see, I can rotate the model, zoom in and out on all the features that are already present on the 3D view. If I go to the results details on the pushover curve, I'm going to be able to see the damage level for each sub-step and for each one of the walls. As we see here, which percentage of the wall is damaged, and we are going to be able to see those results differentiated for each one of the elements, masonry, reinforced concrete, etc. Also, I can take a look at the displacements for each one of the nodes and the relative interfloor displacement. Of course, at any substep that I want to choose to do so. In the bottom right part of the screen, I can see the pushover curve, and by selecting each one of the substeps of the curve, I'm going to see that the distorted wall image and the distorted level plan are going to be updated automatically. I can, if I wish to do so, define a new last step for the pushover curve, and with the auto run feature, I'm going to play in sequence all the sub-steps of the pushover curve. This is going to give me very valuable information in terms of how let's say, the damage of the structure evolves as the forces increase. If I go into the interrogate capacity curves window, I'm going to be able to see all the capacity curves for all the analysis that I just made. And if I open the results map, it's going to give me specific results for different levels of the structure, different type of forces such as shear or perpendicular forces at each one of the substeps. As we see here, it's going to show me the specific result for each one of the piers. I can open up the legend to see the shear, how it changed along the structure. I can, from the list, the drop-down list that is located in the upper part of the window, I can choose between different walls, different types of display results that can be tie rod forces, reactions, etc. And I can change the wall scale deformation factor to get a more clear view on how the walls or the plane view are distorted for each one of the steps in the pushover curve. Finally, a warning sign, it's going to appear if there are warnings in the currently analysis that I've selected, so I can quickly find what areas need to be improved. To continue with the global verification of our structure, we are now going to perform the global static verification, which is to say the general verification of all the masonry piers subjected to vertical forces. Once I click on the button, the results window is going to open, and similar to the pushover results, it's going to divide the screen into 4 sections that are going to provide relevant information about the verification state of all the walls and all the masonry piers located on the walls of the structure. If I click on the details icon, I'm going to see more information about the verification of each one of these masonry piers, and also I have the option to display filters, to activate the 3D view, also to select the objects by number, and to select masonry or other elements. Another feature in our analysis is the model analysis. In the model analysis, the first thing that we are going to do is to choose the amount of vibration modes of the structure that we want to calculate. So in this case, I'm going to see again the screen divided into four sections that are going to show us the all the modes, all the vibration modes of the structure. As I can see, as we can see on the table, I am going to be able to see the amount of mass that is activated on each one of these vibration modes, and also the percentage of that mass that it's going to be activated during an earthquake. Later, I've got some more options such as the sensitivity analysis or the bending out of plan mode. To communicate the results of our analysis, we are now going to make a report that is going to showcase all the results of the analysis that we just made. For this, we are going to choose File Report and then Global Verification to create a new one. Then, after we save the model, the report window is going to open up and it's going to provide us with some options such as the language in which we want to make the report and the different chapters that we want to include in our report. For now, we're just going to leave it as it is and then click on preview to, to make our report. After a couple of seconds, Microsoft Word is going to open up the preview of the report. First, we're going to be presented with a brief introduction along with some images of the structural model, then a 3D view image. Then, of course, we're going to be able to see the presentation of the materials and the geometric characteristics of all the elements inside the model, along with some formulas on how the sum of the main aspects were calculated. Then we are going to have the pushover analysis along with the complete information and some summary tables that are going to summarize all the information of the verifications that we made. So that's it for our product presentation of global analysis in Tremuri. So thank you everyone for your attention. Don't forget to follow us on social media and also don't forget to subscribe to our YouTube channel where you can find our latest videos, presentations, and tutorials.